Okay, for number 4 here, we're going to put this whole thing together, and we're going to find what's called the difference quotient. And the difference quotient is actually, okay, in reality, all it is finding rate of change. Okay? Or what's the same thing as rate of change? Slope. Okay? All it is finding slope, rate of change. Okay? And the thing about it is that this is important that you are able to get this, and it becomes quite difficult for some students. But this is one of the main ideas of calculus, is the difference quotient, because all calculus is basically it's a study of rates of change. Okay? And they just come up with this really cool name called the derivative. And when you take calculus, you'll learn about the derivative, and there's some really easy rules about derivatives that you'll learn when you're in calculus and like that. That makes the difference quotient really easy. But the difference quotient is the basics for it is all we're really talking about is the rate of change. That in letter A, they want us to find s of x plus h. In other words, they want us to put x plus h in for x. Okay, so basically that might be saying that if x was 3, for instance, and I said h was 1, so I'd be finding the value of basically what I would be doing is taking f of 4 minus f of 3, or s in this case. Okay? So all we'd be doing was finding the rate of change of that. Okay? But what we're going to do is we're going to use it and find the general forms that would allow us, if we just stuck a number in there, then we would find it. So when it says find s of x plus h, all we're doing is replacing x with x plus h. Okay? So this is 3 times x plus h squared minus 2 times x plus h. Okay? Now this is where, when we're using the difference quotient, why it's really important that you were able to do the perfect square trinomials. Okay? That you know that a plus b, that quantity squared, is a squared plus 2ab plus b squared. Okay? It's real important to be able to use that because it'll quicken this up for you to be able to do that. Okay? Otherwise, it becomes grueling just because you're spending a lot of time doing x plus h times x plus h. Okay, so the foiling takes a long time. So here I have 3 times x squared plus 2xh plus h squared. Okay, all that is the perfect square trinomial. And then we just need to simplify it. And we won't have any like terms through here when we're done, so I can just distribute the 3 and the 2. Okay? So basically what this says is that I'm taking x, the normal number I would use, and I'm adding something to it. When you get into calculus, that thing you add to it, actually we use really, really small numbers. So we're looking for something that basically, we'll talk about this a little bit later, that's an instantaneous rate of change. In other words, basically at that moment, how is it changing? How is something changing at that moment? So they can determine things like when you're working with specific graphs and like that, you can make them easier. Okay? So now the second thing we do then is that, so we're taking and we added some number to x, and then we're going to subtract the function itself. So basically then we're just subtracting 3x squared minus 2x. So I have this, and now I'm just going to subtract from that 3x squared minus 2x. Now, the nice thing about this is that when you subtract the function itself, it gets rid of everything that does not have an h in it, okay, if you've done it correctly. So when I distribute the negative sign, okay, I get negative 3x squared plus 2x, right? Okay. Well, so I have a positive 3x squared and a negative 3x squared, so those cancel. And I have a negative 2x here, and then I'll have a positive 2x here, and those will cancel. So when I simplify that, we just have 6xh plus 3h squared minus 2h. Okay, and we're not putting anything in there right now. Nope. We will eventually, but not at this point in time. We're not. Oh no, I didn't do that. Yes, I did do that. Oh darn it. Oh, I can get rid of it. There we go. Okay. Sometimes I wonder. There, that looks better. Okay. Then what we're going to do is we're just going to take our result there in B. Okay. So we take our result from letter B and divide it by h. And then since each individual part has an h into it, then I'm just going to cancel an h in each individual section. So 6xh divided by h will be 6x. 3h squared divided by h is 3h. And negative 2h divided by h is negative 2. And so then this is my answer. So it's a matter of we are to find the difference quotient, and when you're doing it, you can break it up into individual pieces like I did here, or you can just write it all. You can just put it all in like we did, like letter C is set up here. This is, at letter C, it is the difference quotient, and you can just put it all in at one time if you want. The x plus h gets kind of confusing, but you have to remember that one thing, that whenever something's in a parentheses and it's a function, that just means I take that thing and I replace x with it. Okay? It's just like, I mean, basically all it is the same as what you did here for number 3. It says g of 1. So what'd you do? Put 1 in for x, right? So g of negative 3, I put negative 3 in for x. So then here it says s of x plus h, so I'm going to replace x with x plus h, and then simplify it. So that's just a difference quotient. Okay, so because none of you did that part. How many of you did that part? Okay, a couple? All right, good. Okay, did you have it right? What? Okay, all right. Okay, now example 5 says determine whether each equation defines y as a function of x. So what you have to do is you have to solve for y. Then you can test the value for x. If you get one answer, it is a function, but if you get 2, it's not. Okay, so when would I get 2 answers? Okay, what? When you have to factor it, okay? You would get 2 answers. Or we'd get a radical, because if we're solving an equation and you have to take the square root, then you get what? Plus or minus, okay? And so anytime we would get plus or minus means then we would have 2 answers. So if we have 2 answers, then it's not a function because those 2 answers are values for y. So we would have one point above the other, which means it would fail the vertical line test, okay? So for letter A, if you solve that, you get y equals the cube root of 16x minus 11 halves. And for letter B, if you solve that, you get y equals plus or minus square root of, that would be 2x plus 3. And so for A, the cube root is always only one answer. Okay? The square root is 2. What other kind of roots would be more than one answer? Any even number. Okay? Is that what you're going to say, Rachel? Yeah. Okay, good. So here we go. We've got, do you have these lines on your paper here? Yeah. Okay. So these types are always functions. What is it? Okay. When y is raised to an odd power. And these types are not functions when y is raised to an even power. Odd power, it's always a function because we can do the cube root, fifth root, y equals. We know there's only going to be one answer in those cases. But anytime I have an even power for y, I'm always going to end up with a plus or minus. And so that would mean there would be two answers. Did anybody want me to go through and solve them? Okay, because you're not going to need to do that as long as you know these two. If you can complete these two sentences and understand them, you'll never need to do that right now. Okay? But it's fun. Okay? All right, so I'll do letter A then, just for. No, it's okay? All right. All right. Never mind, I won't then. All right, so for letter A then, if we're solving for y, that means we need to move the 32x and 11 to the other side. So we have 2y cubed equals 32x minus 11. Then we divide by 2. So y cubed equals 32x minus 11 over 2. And to find y, then we have to take the cube root. So y would equal the cube root of 32 over 2 is 16x minus, and if you wanted to, you could put 5.5 or 11 halves either way. Okay, Sydney? All right, good. Okay, domains. All right, when a rule of a function is given by a formula, its domain, the inputs, is determined by the following convention. Unless information to the contrary is given, the domain of a function f consists of every real number input for which the function rule produces a real number output. Okay, and so we have to think about when are there. Okay. So anyway, so you have to think about what things cause problems in graphs. Right. Okay, so the things that we have problems with is we know that we can't divide by 0, okay, and we can't take the square root of a negative number, okay, or an nth root when n is even. So what happens so letter A here, we have f of x equals 3 over x plus 4. Okay, and why can't it equal negative 4? Okay, we can't divide by 0, and what does that produce graphically? No, it does not produce a whole. It produces a vertical asymptote. Okay, there's just a gap there. All right, so Letter A, the domain for that one is that x cannot equal 3, or negative 4, excuse me. And that's all you have to write, is x is not equal to negative 4. When it's a square root or a radical, we know that we cannot take the square root of a negative number because you won't produce a real number. It'll produce a complex number, but we're concerned about real numbers. So anytime I have a radical, then we're going to set what's under the radical. So that number we know has to be greater than or equal to 0. So then we'll just solve that inequality. So 1 is greater than or equal to 3w. If I add 3w to both sides. So then the domain here would be w is less than or equal to 1/3. I need the w to be positive. Okay. By doing this, I didn't have to worry about turning the inequality the other way when I divide by a negative. Okay. Yes. Yep. What? I can't take the square root of a negative number. So what's under the radical has to be 0 or positive, okay, which would be greater than or equal to 0. Okay. All right. Number 7. All right. Now, some real-life application problems or real-life situations are going to include values where the domain is not all real numbers. And so we have to make sure we keep that in perspective when we're solving problems that involve real life. So here, Robin cleans small passenger airplanes. At most, she will clean 24 airplanes per month. Robin pays a license fee of $150 per month to the airport. Her cost per plane, cleaning supplies, commute to the airport, and salary of a helper is approximately $82.50. She charges $229 to clean each plane. So let X represent the number of planes she cleans in a month. Okay, so go ahead and read through that again on your own. Is that better then? So letter A says to express Robin's revenue monthly, or her monthly revenue as a function of X. So what's her revenue? Revenue is the same as income. What does she get? 229. Okay. So 229X is her revenue. Okay. That's how much money she takes in. Yes, sir. No, we're talking about just how much money she brings in. That's her income. We're not talking about anything else yet. Okay? All right, revenue is only when somebody pays you money, that's your revenue. However much they give you, that's it. Okay? You don't take anything else into account when you're talking about revenue. Okay? Now, her monthly expenses, or her cost, now that involves the fact that it costs her $82.50 per plane, and it costs her $150 per month for the license fee, right? Okay. Sydney, what? Okay, 150 plus 82.5x. Yep. Costs her $150 for a license fee plus $82.50 per plane. says find the rule and the domain of the monthly profit function P. All right, so that's profit. So we're trying to find profit. Profit is revenue minus costs or income minus expenses. And so we'll take that 229x and then we'll subtract all the expenses that go along with that, so we get 229x minus the quantity 150 plus 82.5x, which gives us 146.50x, 146.5x minus 150. Okay, so if she doesn't clean very many planes, she's in trouble. Okay, all right. Now, when it comes to domain, then you have to think about what she can do. She could either clean 0 planes up to 24, because it says she can clean at most 24 airplanes. Can she clean partial airplanes? I mean, she could, but they're either going to count it as a whole airplane or no airplane at all. So then we have to designate the fact that x must be an integer then. What's that? Integers are positive and negative whole numbers, okay? So you could actually have said whole numbers here also instead of integers, okay? Because whole numbers start at 0. You couldn't have said natural numbers, though, because that starts at 1. All right, we have 2 more. Yep. You were only supposed to do 1 through 6. So we're right. Okay. All right, piecewise functions. All right. What a piecewise function is one that for a certain length of time you use one function to calculate values, and for another amount of time you would use a different function. Now, an example might be of a piecewise function that you'd be used to is the fact that how many of you have ever ordered a group of shirts or a group of anything? Okay. All right. Like when places buy shirts, for instance, or if you order shirts from a company in a magazine, they'll say there'll be different prices, right, for different amounts of shirts. So if you buy 15 shirts, you'll pay one price. If you buy 30 shirts, you pay another price, and so on. Well, that's basically what a piecewise function is allows you to determine under certain situations how much money they're going to charge you. Okay? So here we have this piecewise function. And this is one from the book, and then we'll look at the one you have on your sheet. Actually, I'll have you do that one. All right. Now, notice it says that f of x equals 2x plus 3 if x is less than 4. So any values that are less than 4, I will use 2x plus 3 to calculate the answer. Okay. It says x squared minus 1 if x is greater than or equal to 4 and less than or equal to 10. So if a number is between those two, then I'm going to use x squared minus 1. If a number is greater than 10, then I don't have any solution for that because I don't have a function that represents that. And later on, we're not going to do this today, but later on, your calculator will actually graph piecewise functions too. So, all right, so for letter A, it says to find f of negative 5. Right? So is negative 5 less than 4 or between 4 and 10? Okay, it's less than 4. So then I will do, to find f of negative 5 then, I will do 2 times negative 5 plus 3. Okay? I only get one answer. I don't put it in both of them. I only put it in one where that restriction is there. So this is equal to negative 7, negative 10 plus 3. B says to find f of 8. Okay, so does that go? So is 8 less than 4, or is it between 4 and 10? Okay, it's between 4 and 10. So to find f of 8, I will do 8 squared minus 1, get 63. Yep. Okay. So, the domain of it. All right. The top one says that x is less than 4. So that means I'm starting from negative infinity and going to the right, correct? Okay. And I get to 4, and I would have an open dot if we're talking about a number line. But then when I go to the bottom one here, then I have x is greater than or equal to 4. So now 4 is a closed dot, right? So I'm still going there. All right, and it's going to go all the way to 10. So my domain here is going to be that x is less than or equal to 10, because it includes every number up through 10. Okay, so you do number 8 on your handout. All right, so we put 0 in. 0 is less than 3, so we would just use the 2x plus 15 for that one and get 15. 3.5 is not less than 3 or greater than or equal to 4, so there's no solution for that one because it doesn't fall in either of those areas. And 4, h of 4 greater than or equal to 4, so I do 3 times 4 squared minus 15. Make sure you square the 4 before you multiply. Big problem that people have when they're, going back to not using your calculator at times, okay? All right? It's having multiplication errors. All right? Okay, last thing, greatest integer function. And this is found by they use brackets for the greatest integer function. So when we do interval notation, we use brackets. They use it for the greatest integer function. And what that's basically called is the rounding down function. Okay, so we're going to, for any number x, we're going to round down to the nearest integer less than or equal to x. Oops, stay there. Okay. So, letter A, negative 209.99. What's the greatest integer less, or what would I round down to with that? Negative 210. Okay, because we're rounding down, so it's the next one less than that. So that would be negative 210. Okay. Not 200, not negative 209. Okay. How about negative 51? Okay, it says less than or equal to it, so that would still just be negative 51. How about negative 5/4? So it's negative 1.25. Okay, we round down, that means we're going to the next number smaller than that, would be negative 2. So we're rounding down the next number below it. And square root of 10. Okay, the square root of 10 is bigger than 3 but less than 4, right? Okay, so if I round down, I'm rounding down to 3. So this lesson is just working with functions. Okay? Some of them that you're very familiar with, other ones that are new. The most difficult one is going to be, for some of you, will be doing the difference quotient. Okay? And when it asks you to do the difference quotient, do it in pieces like this, if that helps you. If you can do it all at once, then that's fine. But it might help you the most if you do it in pieces by doing s of x plus h, then subtracting the function, then dividing it by h.